Hi friends, today we are going to discuss the topic known as Instrumentation Amplifier and we will explain its operation. Okay. First of all, in a number of industrial and consumer applications, one is required to measure and control physical quantities. Okay. This function is performed by an instrumentation amplifier. This is one of the common definition, and I'll say some of the important features also. The important features of an instrumentation amplifier are: it has high gain accuracy and high common mode rejection ratio, and it has high gain stability with a low temperature coefficient. It has low DC offset, that means it has low direct current offset, and it has low output impedance, and it has high input impedance. First of all, we will know the construction of instrumentation amplifier. What are the components or ingredients that we need during the construction? See, we need three op amps. They are nothing but A1, A2 and A3, and we need how many resistance? 1 2 3 4 5 6 7. We need 7 resistance and 1 load resistance, and we need two voltages V1 and V2. V1 and V2 are the two voltages we are needed, and here there is a current flowing. This current is known as I2, and here there are two nodes A and B. Now we can see there are divided the instrumentation amplifier into two parts. They are nothing but two op amp difference amplifier, and other one is single op amp difference amplifier. Okay friends, we can see when the node B is grounded, op amp when the node B is grounded, op amp A1 along with the resistance R1 and R2 acts as non-inverting amplifier, and therefore the gain of the op amp A1 is given by AV1 plus R1 by R2. Similarly friends, when the node A is grounded, the op amp A2 and the resistance R3 and R2 acts as non-inverting amplifier, with the gain of the op amp A2 is given by 1 plus R3 divided by R2 is the gain that we obtain. Afterwards we can see with the voltage with V1 and V2 sources acting. See, here we can see that V1 and V2 are the sources acting. That means these are the two input sources acting. The current I2 is flowing through the resistance R2. Okay, as you can see in the figure, the current I2 is flowing to the resistance R2 as. Therefore, the current I2 is given by the formula VR2 divided by R2. What do you mean by VR2 is nothing but the voltage that is present in the R2 divided by the resistance R2. This formula is, as we know, that is through the Ohm's law, and therefore what do you mean by VR2 can be expressed in the form VA minus VB divided by R2, and this can further be expressed as V1 minus V2 divided by R2. Okay, we know that this is an difference amplifier. That means the difference of these uh, the difference of the two voltages acts as the input into op amp difference amplifier. Therefore V1 minus V2 is expressed as Vi, and that is the R2 is given as the same value divided by R2, and the value I2 is equal to Vi divided by R2 as equation number 1. Now we can see, after seeing the working of these components, now we can see what is the value that we obtain at the output. The differential output voltage is given by V naught, that is nothing but V naught is equal to I2 into R1 plus R2 plus R3. Here we know that in all the three resistance the same current I2 is flowing, therefore I have taken the I2 as common, and in and the those and the resistance that are present are R1 plus R2 plus R3. Okay, that will give me the output voltage. From the equation 1 we know that the value of I2 is equal to Vi divided by R2. We can substitute the value of I2 is equal to V0 is equal to Vi divided by R2 into R1 plus R2 plus R3. Okay friends, consider R1 and R3 is equal. In this condition we can substitute the either the R3 value as R1 or R1 value as R3. Let us consider we will take this R3 value as also R1, because as these both where R1 and R3 values are same, therefore we will get the formula as V0 divided by Vi. Here the input voltage is sent to the left hand side, and therefore this output or voltage divided by input voltage will give us the differential voltage gain. That is nothing but a differential voltage gain is given, and therefore we will get the formula 2 into, that is nothing but 2 into R1 plus R2 divided by R2, that can be expressed as 1 plus 2 into R1 divided by R2. See, this is the gain that is obtained by the 2 op amp difference amplifier. So the differential voltage gain is adjusted by varying the single resistor R2. See, this R2 is the major component which adjusts the overall gain of the 2 op amp differential amplifier. And similarly, common mode gain of a 2 op amp is given as V1 is equal to V2 is equal to Vn. Okay, Vn. Therefore, we can substitute that value in the current I2. Okay, when the common mode gain of 2 op amp difference is given with V1 and V2 is equal to Vn. Okay, here we know that as we have previously discussed, the value of I2 is equal to Va minus Vb divided by R2, which is also equal to V1 minus V2 divided by R2. We have seen here in common mode gain condition the V1 and V2 is equal to Vn. Therefore substitute both V1 and V2 by Vn minus Vn divided by R2. Therefore the value of the current flowing in the common mode gain condition is 0. Therefore in this condition no current flow through the R1, R2 and R3, and the output voltage of the each amplifier will be Vn volts. Okay, in this condition, in the common mode condition, the value of the current flowing through these three resistance is 0, and the common mode signals will be passed through therefore the common mode signals will be passed through but not amplified by the two differential op amp. Therefore the common mode gain signals will pass through these resistance, but they are not amplified by these op amps. Okay, therefore the common mode gain condition in the two op amp difference amplifier is 1. Okay, next we want to see the advantages and disadvantages of two op amp difference amplifier. This is one of the important concept, friends. So the advantages of two op amp difference amplifier is gain can be varied by the single resistance R2. See, the overall gain of the two op amp difference amplifier can be varied by a single resistance R2. This is one of the major advantage of the two op amp difference amplifier, my dear friends. And here the other advantage is it has high input impedance. Okay, these two op amp difference amplifier has high input impedance. And the disadvantages of this two op amp difference amplifier is here it has a floating load. Yes, here it has a floating load, and the common mode gain is 1, as we have discussed above. Therefore this is the construction and the working of two op amp difference amplifier. Next we can see the single op amp difference amplifier. Okay friends, the advantages of single op amp difference amplifier is the common mode gain of this amplifier is 0, and here the load resistance is grounded. Okay, this is one of the advantage of the single op amp difference amplifier, and the disadvantages of this amplifier is low input impedance. See, it has very low input impedance, and here the gain variation is done with the two resistors. Okay, here the gain variation is done with the two resistors. And see, in two op amp difference amplifier, the gain variation is done by only one resistance R2, but here the gain variation is done by two resistors, and this is one of the disadvantages of single op amp difference amplifier. Okay friends, now we have discussed both these amplifiers. Okay friends, by cascading both these amplifiers, we can achieve the features of instrumentation amplifier. See, we have founded the voltage gain of both the amplifiers. If we multiply both these gains of both these amplifiers, then we will get the gain of the overall circuit. That means then we will get the gain of the instrumentation amplifier. So what is the formula of the gain? The formula of gain is AV is equal to AV1 into AV2. Okay, here first we can substitute the value of AV1. AV1, the value of AV1 has been found is 2 into R1 plus R2 divided by R2, comma, the value of the
The
gain is
gain
equal to
AV2 is equal
R5
to
divided by R4. Value of the gain of the single op amp difference amplifier is R5 divided by R4. Here we have considered the value of R3 is equal to R1, and in the first two op amp difference amplifier condition, and in the single op amp difference amplifier we have considered R4 is equal to R6 and R5 is equal to R7. After applying this condition, then we will get the gain of both these amplifiers. Now we will look at the overall gain of the instrumentation amplifier. Okay friends, the overall gain of the instrumentation amplifier is given by 2 into R1 plus R2 divided by R2 into R5 divided by R4. So the final point is the overall gain can be controlled by the adjustment by R2, as the overall gain can be controlled by the adjustment of the resistance R2. Okay, this is the overall operation of the instrumentation amplifier, my dear friends. First we discussed about the two op amp difference amplifier operation and its working. Initially we discussed about its features, and then the working of this amplifier and the working of single op amp difference amplifier. Later we cascaded both these amplifiers and we obtained the feature of instrumentation amplifier, and we found the gain of the instrumentation amplifier. That's all for today. And my dear friends, if you have any doubt or any queries, please you can comment below, and for more subscribe our channel. Thank you.